So in this case, we are supposed to find using the definition of the derivative to differentiate the following. So we are given that f of x is equals to root of 1 minus root of x. So either we are going to use these two, one of the two definitions. So this one is the limit as z. So f prime is equals to the limit as z approaching x of fz minus f of x minus z minus x. Or you can use the limit f of f prime of x is equals to the limit as h approaches 0 of f of x plus h minus f of x over h. So we'll start with the first one. That is the one which we used first. Okay, the one for z. So where there is x, you substitute z. That's what it means. So you put a z, you put a z. Now you have fz. That is your fz. Fz, fz, still the same. Minus root of x, which is f of x. So it's minus root of x over 1 minus root of x. Okay. So you just come and just plugging it as it is according to the definition. So the limit of z approaches x of fz is this part, fz, minus, so that's your minus f of x. So this is f of x. Okay, f of x. Everything over z minus x. Everything over z minus x. Okay, so now we come, we say f prime of x is equals to the limit as z approaches x, that is everything. Okay, so dividing by z minus x is the same as multiplying by 1 over z minus x. So I just push the denominator so that I can deal with the fraction at first. It might be a simpler way. Okay, so I find the common denominator of both 1 minus z, square root of z, and also 1 minus square root of x. So the common denominator is just that multiplied by that. It's a common. Okay, then we say the denominator into the common denominator. What do we get? We get this, it cancels with that, then we are left with that. So it will be 1 minus root of x multiplied by that. So it will be 1 minus root of x multiplied by z. Then you take this into that. So that and that, they cancel, you are left with that. So it will be that which is left multiplied by the numerator. So it will be minus root of x, that's your numerator, multiplied by this. Okay, as a fraction. So we are going to simplify this fraction. Okay, and then we see how it goes. So we can simplify it more further. Okay, so from there we said z multiplied by 1, that is square root of z. And then we expand that, multiplied by that, it's a negative square root of zx, minus that multiplied by that, remember it's the square root of x. Negative and a negative gives you a positive, which is positive square root of zx. Everything over that. Okay. And also note that here we changed z minus x. We were dividing by z minus x. So z minus x can be written as square root of z squared minus square root of x squared. If you square this, you get z. If you square this, you get x. So the idea was to write this as difference of squares, because we are trying to avoid to divide by 0. We don't want to divide by 0. We want our z minus x, it must not be 0, because when you substitute x here, it becomes x squared minus x squared, which is 0. So 1 divided by 0 is undefined. So we are trying to avoid to divide by 0. That is the idea why we have manipulated here, because when we replace here where there is z, we put an x, it will be x squared minus x squared. So 1 divided by 0, then it's something else. So we are trying to manipulate this into difference of squares. So it will be square root of z plus square root of x multiplied by square root of z minus square root of x. If you expand this, you get square root of z squared minus square root of x squared, which will give you z minus x. So this is another way of writing z minus x. Okay, then we go multiplied by, so you can see minus square root of zx plus square root of zx, it will give me 0. So I'll be only left with square root of z minus square root of x, square root of z minus square root of x. Okay, that's what I will be only left with, divided by the denominator. So I'm going to simplify it further. So you can see that this numerator is cancelling that denominator because they are the same. Z minus root of z minus root of x cancelling with that. Okay, so it will be that by that, it cancels. Then we'll be left with 1 over this, which is square root of z plus that, multiplied by 1 minus square root of z, multiplied by 1 minus square root of x. So f prime of x, that will be the derivative. Okay, f prime of x is equals to the limit of that. Alright, so we are trying to divide by 0. If we can reach a point whereby we can't divide by 0, if we substitute x, where there is z, you put an x. For example, where there is z, you put an x. Can you see? To be root of x plus root of x. Where there is z, you put an x. 1 minus root of x multiplied by 1 minus root of x. So you find out there is, in this case, you are not going to divide by 0. You can't divide by 0. Unlike at this point. At this point, you will be dividing by 0, because when you put z here, it's going to be x squared. When you put z where z is, you substitute with x, it will be x squared minus x squared. Okay, so it will be 0. So we are trying to avoid by dividing by 0, even at this point. So when we reach here, we'll find out that no, this can cancel with that. So we cancel them. So now we have avoided the 0. Now we can replace z with x. So where there is z, now you can simply plug in your x. That was the idea why we're running away from 0. Okay, so from here we simplify it further by just putting where there is z, you put x. Okay, so replacing x, z with x, we come and put where there is z, you put an x, where there is z, you put an what? An x, yeah. So you'll be left with, and remember when you are now replacing z with x, you don't write this limit. You're just going to come and say it's equal to now. So the time when you're replacing z with x, the time when you're going to replace, you don't have to write this limit. Z approaches x. You come and just substitute directly. You are not supposed to write this again. Okay, so that we know now that's when you are now substituting z with x. So you come and replace. Where there is z, you put an x. Where there is z, you put a what? An x. So after we put everything, we are going to see that root of x plus root of x is 2 root of x. Okay, and 1 minus root of x multiplied by 1 minus root of x. Remember, it's a bracket multiplied by the bracket. These brackets are the same. So squared, which means the bracket times the bracket, which is the same, which is squared. So the answer is 1 over root of 2 bracket 1 minus root of x squared. So you can also verify the solution using quotient rule here. Remember, here we're using the definition. So you can verify if your answer is correct. using quotient rule. So quotient rule says what? The denominator, that is our denominator, multiplied by the derivative of the numerator. If you differentiate the numerator root of x, you get half root of x to the power negative half. So the power negative half is just over root of x, half, that is 1 over 2. Okay, so the derivative of root of x is 1 over 2 root of x. And then minus, since you started with the denominator, now you are going to start with the numerator. So it will be minus the numerator, you differentiate the what? The denominator. If you differentiate 1, you are going to get 0. So 0 minus, what is the derivative of the root of x? We found it is 1 over 2 root of x. So it will be negative 1 over 2 root of x. You divide everything over the denominator squared. So the denominator squared, that will be your answer. So 1, can you see 1 multiplied by that? It will give you positive root of x. Minus root of x over 2 root of x. Minus positive. So this and that, they will cancel. Okay, they are going to cancel. So which means if we simplify negative root of x over 2 root of x, the root of x will cancel to give us negative half. Okay, negative half. Let me just put it there so that you can see. Okay, so that is what I'm just trying to say here, that if you multiply that by that, you are going to get a negative. Negative times negative gives you positive. Okay, so if you add in the 2, it will give you 0. So minus, 1 over 2 root x plus 0 is just 1 over 2 root x over that. So it will simply give you the final answer, which is 1. Okay, so you can see that these answers which you are going to get from here, after you have verified with the quotient rule, is the same by using the definition of the derivative, which means from first principles. So the answers are the same. Okay, so basically this is how we'll be doing it. Just forward your problems which you are having challenges with, then we can explain using video explanations so that it's clear and it's understandable. Where you don't understand, you are still able to replay the videos. It's not the same whereby the tutors, when they erase the board, then your memory has been erased. With us, you can replay our videos and then you get to understand each and everything. Okay guys, cheers.